So Christian Mogensen back there says there are two things in software development which are really, really hard. One of them is cache invalidation, and the other is naming things, as I think we have proved. This talk is in two parts. Me talking about archive providers, how to adapt them, how to improve them, is a tradition here at ExtenderExtenders. I haven't actually looked back in history, but I feel there's something familiar about this. But I try to invent something new for you every year. So last year, how many of you were at the archive provider talk last year? Okay. Maybe someone else who doesn't remember. The last slide last year lamented the fact that some providers are easy to extend, some are harder to extend. Selection is particularly hard. It's hard to share code between providers, and so on. So I'll just recap. An archive provider in NetServer is either based on one database query, or it is a multi-provider merge framework. So the activity archive is a typical example of a multi-stream merge because it contains activities and documents and requests and mailings and lots of other stuff. So that is a multi-query merger. But each of these channels results in one query to the database, one SQL statement being executed and returning one stream of data. And that's what archive providers do. They return tabular data, columns and rows. And most of the work of an archive provider is farmed out to elements that I call extenders. And each extender typically handles data on behalf of one table. So that means you have a contact extender base. This is a class that knows about the company columns. Now, the table is called contact and person. And unfortunately, it got translated into company and contact 25 years ago, and we're stuck. You have an appointment extender base. That's the thing that understands the fields of the appointment table, how to interpret the date, and so forth. Multi-query provider base is a base class that handles the case where multiple providers deliver the data stream, one stream from each, and it looks at the sort order to find out which stream has the next row. It picks the row. That query provider is then asked to provide its next row, and so it goes until we either have returned the number we were asked to or we run out of data. Code reuse is very important. When the archive providers were designed, we had not as many archives and not as complex archives as today, but we still had a lot of complexity. The activity archive is particularly hard because it has complicated rules. When you are showing the activities for a company, if you have a booking, an activity with multiple participants, there are multiple records, all linked to the same company. But we only want to see one of them. We don't want to see all the duplicates. We also have to take into account the visibility rules. We have to take into account the filter criteria, which say, I don't only want to look 2 years back, I only want to see activities come from these groups. So there's a lot of logic. And there was a very strong desire to make the system so that this logic could be reused, because at that time, in the Windows client, we had several incarnations of this logic, and trying to keep it synchronized and trying to keep it updated when features changed was quite unpleasant. And so we ended up with this system where we have an extender base class that works for one table, and we compose an archive provider out of these classes, depending on what it is we actually want to do. And so we end up with a graph like this. On the left side, you have the database. You have the contact table, and you have person, phone, and email tables which are related to it, which have pointers back to the contact. And then you have another set of phone and email records which point back to person. And no pointing device. I'll use my finger. Then in the code, we have a class called ExtenderExtender, meaning it starts off the whole hierarchy. It's the root. And then underneath that, you have a contact person extender. Contact person extender is a class that extends a contact with person information. So it corresponds to the database diagram. Thank you, sir. Which end blows up when I press it? Ah. Did you see it? No. So the contact person extender is a class that derives from person extender base because it handles the person table, but it's called a contact person extender because it embodies the code that knows that it has a contact parent and it adds person information. And similarly, you have a contact phone extender, which is a class that inherits phone extender base because it supplies and handles phone columns, and it links an instance of the phone table to the contact. Similarly, you have a person phone extender, which inherits from the same phone extender base class as this one did. But the special thing about this class is it's constructed to have a person as its parent. So the code in this class consists of the join that says phone owner ID equals parent person ID, and phone type index equals or greater than 16,000 to get the correct records linked up. This class contains a similar line of code, except the constants are different. And it assumes, it requires, strongly typed, it requires that the parent exposes a contact table info. This one requires that the parent supplies a person table info that it can grip onto. And that is how we build some fairly complicated providers. And you can imagine in the case of sale with stakeholders, you have the sale table, you have person, project, contact directly on the sale. On each of them you have phone and URL and email. And then on person you also have text, and on sale you have text. And on sale you also have stakeholder, and a stakeholder then is a person who in turn has phone and address and stuff, and it kind of goes on down. But we're still the logic that understands how to construct a person full name based on your current settings, preferences, and the contents of the first name, middle name, if used, and last name fields. That logic is just in one place. It's in the person extender base class, which all of these different person instances inherit from. So I get a very high rate of code reuse, and I get a structure of the code which is very close to matching the structure of the database. And once that is firmly established, the code and the naming conventions become if not beautiful, then at least understandable, I hope. So when you see an XX extender, that means it's a root. And when you see a XY extender, it means it hangs off this one and it supplies this one. And that means it inherits from the second part extender base class. So far, so good. And so a provider, query, all of these guys belong to someone who owns the SQL query being built. Each of these classes will contribute to the query. It will, if you have requested columns, it will add whatever fields to the query it needs to construct those columns. But none of them actually own the SQL query itself. That is the job of the query provider, which is usually created by inheriting from the query provider base, which gives you about 10,000 lines of code that work for you and make your job simple. And typically, a query provider will construct the root extender and maybe pass in some options. So this one knows how deep a tree it should create, and that's about it. But the provider might add special functionality, such as if it's the activity provider under the company card, where then we need to actually have a restriction on which contact ID all those appointment records should come from. And that is generally the job of the query provider, to do things like that. And there is an extensibility mechanism built into this, which says that you can extend query providers by creating a class that implements some certain interfaces. And the easiest way of implementing those interfaces, as long as you're working with the database, is to inherit from a base class. So, and then you put in an attribute that says, this provider name is the one that I'm going to extend. And my extender has a name. It doesn't really matter what it is, but it has to have a name so we can properly get hold of it. And then you implement whatever code is needed. And you don't actually need too much code to add a couple of columns. So here we declare the columns, here we do the join, and here we map our columns to some fields in the database. And as you can see from this syntax, this is probably a table created using the service extra table functionality. So far, so good. So what's the problem? The code you previously saw extends one provider, which is excellent if that is what you want to do. But often it seems that's not exactly what we want to do. We want to do something more generic, like every person, or we want to extend the person object itself. Like everywhere we have a person, we also want the person's religion or boot size or whatever it is this new information that we want to add. And that is pretty hard to do up till today, because you actually have to extend each provider where you want this to happen. And some people have done so, and well. So we have this term of dog fooding. I'm a cat person, but it applies to cats as well. Meaning we should use our own code, right? We should eat our own dog food. And so I was asked to add some new fields to person everywhere in SuperOffice for our own installation. And when I looked at what I would be required to do, I felt like this guy. I don't know if you have ever tried to offer your cat a salad. I have a cat, and if I offer him a salad leaf, he looks at me like, why are you doing this? So I thought, there has to be a better way. Now there is. And that's why we introduced this beautiful self-explanatory name, the ExtenderExtender. Because what we were doing up to now was to extend an archive provider. So we had an archive extender. But what I want to do now is to extend an extender itself. It's a different kind of target. It's the same concept, but the target is different. Instead of saying, every time this query provider is invoked, attach my code, I'm saying, every time this extender class is invoked, attach my code, which is a far more powerful concept if you want to do things generically. And the targeting includes inheritance. So if I say, whenever person extender base is constructed, please attach my code. That means anywhere in the system where the person columns appear, they are handled by a class which is derived from person extender base. That wakes up the factory and attaches my stuff. And since we are targeting by type, it means I know that my parent, the thing I'm extending at runtime, is going to be, in this case, a person extender base or some class derived from it, which means everything that person extender base does, I can assume that I can do. I can cast my parent to the type that I'm targeting and interact with it strongly typed, which is very useful. I think I'll skip that. Now, everything you already know about extenders applies to an extender. It's the same code. You can inherit from the same base classes, you implement the same interfaces, you can declare new columns, you can process restrictions, you can do things to the SQL statement. You could also fetch data from outside the query, like run your own independent SQL statement or call a web service. I'm saying this because this is actually a question I got. Someone wants to do that. The only thing to watch out for is performance. You don't want to do heavy calls across the internet for each row you fetch. That's going to kill performance pretty badly. So the trick there would be to somehow start up the fetch using the criteria that you have available, cache the results, and as the rows are counted off from the database, find the corresponding. And it works very well. And you've done it?
Yeah, not with the new here, but
yeah.
in the old.
Yeah. Excellent.
It's fast.
Yeah. And so the practical example I'm going to show you is how I added last use to our own SuperOffice database. Last use is we collect usage data from customers who have consented to do so. There's this dialog that comes up, and you can say agree or disagree. And most customers click agree. And that means we get statistical information from them. And from that information, I also get the usernames. So I can find out what was the last date a particular user interacted with a particular client. When did they last use Pocket? When did they last use the sales client? When did they last use any client? And I would like to achieve this, that everywhere we have a person in SuperOffice, we also get these new fields that are populated. If this person represents a user at a customer, then we get this information, and it appears all over the place so that we can target these fields in find, in saint, in static selections, dynamic selections, everywhere. So if we could make sure that that happens, every time the person entity is used in an archive, anywhere, we attach these extra columns, then that would solve the problem. The usage data comes in through a web service. It's stored in a special database, separated from SuperOffice. That's for various reasons. Privacy is one of them. I used service to generate a new table inside the SuperOffice database. Very simple one, looks like this. It connects to a contact ID, and it has the date time for the last sales, last service, last pocket, last win, last admin. There is a periodically running program that takes the raw data and populates this table. And the details of that program don't matter. The point is, I have this table, it's updated every night, and that is the target of my new archive extender. And I'm targeting person extender base because I want it everywhere. The columns in the table are simple date columns, so I don't actually have to do any special processing. All I have to use is inherit from the usual base classes and then tell them that column this maps to database field that, and the base class functionality will do the rest. It will do the fetch, the formatting, process restrictions, and so on. And so the usual method called inner modify query is used to do that binding. And that gives us searchability and sorting and everything for free. The set join method is used to create the join to the parent person. Inner populate row from reader is a method. If I just wanted the dates out, I wouldn't have to override that. But I want to make a custom tooltip so that on any of the dates, you get a tooltip that shows all the dates for that person, because I think that might be useful. And it also is a good illustration of how all of this puzzle fits together. So I also need my own tooltip plugin. And extra tables don't have generated net server code. I can get hold of the table using get table info with the name, and I can get hold of the field infos using find field. But it's error prone to keep writing that all the time. So I'm going to cache that lookup somewhere. And for that, I would like a kind of singleton where I can look up that once and for all. And a good singleton mechanism is to use the class factory with a database lifetime and context, so that this would work in a multi-tenant environment as well. And it's 220 lines of code, and that's enough for everything. So let's switch to that. First, you see, I'm making an archive extender, and I'm targeting the person extender base. You see, type of. So this is strongly typed targeting of a certain class, base class. I want to do view and full screen. And I want this. Oh, that's wrong. I want this to go away. I'm declaring columns in the usual way. If you declare them with underscore call something, the base class is going to pick them up by reflection, so I don't have to do much else. I have this last interaction cache object, which is where I store my lookups. So everywhere I need it, I go to class factory and say create. The first time I do that, it's actually going to call the constructor and instantiate such an object. Later on, the class factory is going to just keep it in its instance container and give me that one. If someone then logs off the database, the whole instance container dies and it goes away. So I get the correct lifetime of my cache that way. And all I do in the constructor is set the icon hint so that my columns show up under person and not something else. In inner modify query, I simply map my fields. This is from my cached lookup of field infos, because this method maps a column to a database field. So I'm simply doing the mapping. The join looks a little bit complicated because we have to go from person via the foreign key table to the last interaction table. The details of this don't matter, but what's interesting is I can do this. Parent table to extend as person table info and expect it to succeed. And this I can do because my attribute says this class is targeted towards a person extender base derived class. And I know that person extender base has a table to extend property, which is always a person table. So I can do this. And now I have a nice, strongly typed way of setting the join. Due to time constraints, I have to skip lots of interesting details here. I hope it doesn't matter too much.
Be able to override the set restriction and
Absolutely. Yes. You're in, this is the only difference between an archive extender and an extender extender is actually the targeting. We are not targeting a particular query provider, we are targeting an extender or an extender base, meaning all classes derived from it. So otherwise, this could have been a talk on archive extenders. Same thing.
But that could be always a one-to-one relation, because otherwise you will fuck up your...
Yeah, the number of rows, well, no, it doesn't. But if you cause multiple rows to be fetched and they have the same primary key, the duplicate elimination mechanism will eat them, and you just get the first one anyway. Yeah. Because if you are in an archive provider that has person ID as its primary key, then that doesn't change. If you're in an archive provider that doesn't have person as its primary key, well, then whatever happens, happens.
But if you have, for example, just the last and the sort, you get the last one.
Yeah, but if you can't, as long as you're building on the big query, influencing the order by is tricky because the user might have selected an order by, which might be different from what you think you're getting. So here in populate row, I am creating a custom tooltip. So my tooltip key is going to be last use equals something, and I'm adding the tooltip to all the fields. It's a tooltip hint, so it's not the expanded tooltip, it's just a hint. And that's it. That's enough for these columns to appear in every provider, everywhere in SuperOffice where you have a person. Find, selection, company card, stakeholders, you name it, everywhere. I think that's an improvement. I think we've upgraded from salad to steak. Tooltip. Making a tooltip plugin is not very hard. So I'm saying I want two things in the tooltip hint. These are the string constants that are being referenced up here. I love string constants because they rescue me from typing errors. And again, I'm inheriting from a base class, which does quite a bit of the work. So I'm retrieving the IDs from the tooltip hint, and then I'm running a separate query to get all the dates for this person. And I'm creating a tooltip which contains all the dates if they are set. And again, that's it. This is enough for me to get a custom tooltip. And finally, my cache. So remember, to work with a query, we always use field info objects. Those represent fields from a table in a query. And what I have to do is, I have to do this. I have to get hold of my table info using a string, then I have to get hold of my field infos using a string. And this is what I don't want to write every time. I think it's much easier to just write this than to write this clause and hope that I've spelled it right every time. And so this object, what the constructor of this object does, it is very simple. It looks up the table info, it looks up all the field infos that I'm going to use, and it assigns them to member variables of this object. So it's a straightforward caching object. The magic here lies in this. It says, this is a class that is going to be created by the class factory. So I'm injecting this type into the class factory, and when the class factory creates an instance of this type, it should keep hold of that instance for as long as the database login lives. No, for the database login, which translates to tenant or customer. So if you have a net server who is running inside a web server that is serving one customer, when the first request comes in and we do class factory create last interaction cache, the class factory will look in the instance container which is connected to the database context and see that I don't have one. So it's going to call the constructor, and then it's going to keep it. The request completes, the instance container lives on. The next request comes in, and if it is from the same customer, which it usually will be, then when we say class factory create, the factory will see, I already have one of these, and it's tagged as container database. Right, here it is. No more lookups. So this happens one. Well, this construction, this construction works anyway.
Yeah, but not for us.
And
We can't put it into online.
no, you can't put it into online. No. But you get one thing for free, which is if someone says flush, which calls the flush service, which among other things logs out of the database, then the instance container dies. And this will die with it. So when NetServer then reinitializes back to the same customer, the only one you have, this will get reinitialized as well.
What are the possibilities for the containers? What is the size from database?
You have transient, which means don't keep an instance, give me a new one every time. You have request, which lives for the duration of processing of one request. You have the database, and you have a global one which never dies. I think those are the possibilities. If we, actually there's an easy way to find out. Transient, process, thread, context, database, session. Yeah, So, yeah, those are the ones. Okay, so this illustrates partly how to make an extender, which in principle could have been used both as a query extender and an extender extender. Since it is an extender extender and it targets person extender base, these columns appear everywhere you have a person with no additional work. I think that's pretty neat. I think that's an improvement.
Do we already have that in SR4?
Yes, you do.
Which version was it added in? Is it in
I think it was, I will have to see, but I think it was very early in 8, actually. We've had it in production for quite some time.
Does that currently work in SuperOffice web?
This is part of NetServer, so it works everywhere NetServer is used, both web and Windows client. And also from the outside. I mean, if you're calling, calling in through the services, those columns are going to be there.
What about Windows static selections? Are they NetServer?
Yes,
No? Yeah.
they are. And so this thing appears all over the place.
No, it can be used by CRM scripts as well.
Yes. So it pretty neatly fits into the puzzle. So that was part 1. These are cubic cave pearls. They are known in 4 places in the world. They are about sugar cube sized. Extremely rare. Now, where is my mouse? Part 2 of this talk is about a completely different aspect. No. Of archives. And that is something which has actually been there for quite some time, but we've kept it a secret. And that's the Aggregation Engine. So you've seen the dashboards, and we actually have 2 sets of dashboards. We have the new dashboards in Sail, and we have dashboards that we have had in Service for quite some time. Have you ever wondered how we collect the data? How do we know the count of something grouped by something else? Now, a very long time ago, I worked with a tool called Power Builder. And it had a screen design. It was what was called a 5th generation design tool. It has a screen design. And 4th generation, yes. And it turned out that every screen was actually a report system where you could have groupings and levels and stuff. And you had the detail, and most screens would have empty header and footer and just the detail, but still the functionality was there. And I thought this is something that would have been very nice to have in archives. And so I got together with Sverre, and we set up the Aggregation Provider. And remember, archive providers are strictly defined by the interfaces that they implement. So you don't really know what's inside. And they are created through a factory. So you don't really know what you're getting. You're asking for a contact person provider, or whatever it's called. I think it's called, that archive provider is just called person, the one that shows contact persons under the company card. It's just called person. So you go to the factory and you ask for a person provider. And as long as you get something that behaves like a person provider, you're happy. The actual type doesn't matter. If you do this in the debugger, and you inspect what you actually get, you will find that the return type is of type Aggregation Provider 2. Doesn't say anything about person. And that's the power of the factory mechanism. The factory can choose to give you something it thinks is a good answer. And as long as the answer satisfies the interfaces and your expectations, you're happy. So what we did is we made an aggregation, a generic aggregation mechanism, implemented it in the form of an archive provider, and changed the factory so that every time you ask for an archive provider, you get that one. You get the person provider. The factory doesn't cheat you out of that. But it also creates an aggregation provider, tells the aggregation provider that your data source is this provider I've made here, the person provider, and off you go. So it returns you the aggregation provider. And that turns almost every archive into a multi-level aggregation reporting tool behind the scenes. Now, there is no list user interface for it, so you don't see any functionality in the user interface saying count this, sum that, group by this and that, because we don't think people would understand it, we don't think people would use it. There is an alternative user interface for archives. It's called dashboards. It works with numbers. Same thing there. Yes, they have their own way of doing that. Yeah. Service is, it's a parallel universe. You have heard us talk about this zipper. We are pulling the zipper upwards from the database, and now with the skill project, Jørgen and Sverre, and it's no accident that those two are the ones doing it. They are designing the new user interface components where we are dragging the zipper down from top. Now, what gets stuck in the middle is, and can be hard to get the zipper past, that we'll see.
Can you report in the dashboard on the extended columns, extender columns?
Absolutely. Except there is no user interface to do that right now. But there is no technical limitation because you have these levels of abstraction. The archive providers supply columns. What relation those columns have to their data source, whether they are coming from the database at all, doesn't matter. You don't see that. Whether they are made by me, extended by you, doesn't matter. So it's a bit like you have you sitting on the outside, you have the aggregation provider, you have the plain old archive provider, you have the data source in there. And the question is, how do you activate this guy? Because most of the time, he's sitting there doing nothing. We'll come to that. Now, we wanted to introduce aggregation without breaking the archive provider interfaces. So we're still returning rows that contain columns, and rows have a row type or entity, and that hasn't changed. Still the same. What has changed is that you have the detail rows. That is the rows from your ultimate source. But now you can also get a header, a footer, and a grand total as a separate row type, popping up in between, depending on what's going on. Header and footer rows are generated when a group by value change. So you say, I want to count this, group by that. I want to count number of appointments, group by the activity type. So it counts. And every time the activity type changes in your output, you can get a header or footer row. You can get the details in between, or you can hide them, depending on what you want to do. Grand total is a kind of ultimate group, invisible group that sits around everything. If you ask for that, you get that towards the end. You have all the columns from your underlying provider. and you can use a function syntax to specify things you want to do with them, counting and various kinds of aggregation. So the data source is still always the archive you specified, which in turn can be anything that you have built and extended and worked with. It's just that you can do stuff with the columns, and you can get more rows than just the detail. And you can also suppress the detail if you're not interested in it, which is what dashboards do. The dashboards, graphs, suppress the details. They are only interested in the counts. And so what the dashboards do is something like this. I want to count appointment IDs, and I do not want to see this column in the detailed rows. And I want to group by the record type. I do not want to see this either in the detailed rows, but I do want to generate a footer every time the record type changes, or rather for each distinct value of record type, I want to generate a footer which contains then the count. All columns are shown in all row types as far as possible or sensible. Unless you say, I don't want to see this. And since, let's say this was the complete query, that one says high detail, that one says high detail. There are no other columns to be shown. Okay, so let's not show any detail. That will suppress the detail rows themselves. So you're not getting 500,000 empty rows. That would be rather stupid. And it looks like this. These screenshots, remember I said there isn't a list interface for this, but there is something closely related, which is the archive browser tool. I found out when I prepared this talk that I need to update it a little bit for it to work with all the functions. So the one that's on DevNet right now isn't quite the one you need to use, but I'll push out the update. So you see, we have the count and the group by. I can do order by. I just have to repeat the exact column definition with everything, all the function syntax and modifiers has to be exactly the same, so it's recognized. And I can say, this is my primary sorting column, and I want it to be descending. So I want to count appointments by record type, and I want the output to be, and I want to hide the details. I want a footer for each record type, and I want to order the whole result by the count, descending. So I get the record type with the most appointments first. And that is what I'm getting. I'm getting the count, 4,402, and the record type, appointment, to do, unknown, phone. And you can see the values are going down like this. So this is actually quite powerful. And it's maybe even more powerful than it looks, because these columns, okay, you can ask the database to order by appointment ID. You can't really ask the database to order by count of something. I can't ask the database to count because I have to pass everything through the sentry first to see what's visible. So there is a certain amount of buffering going on here, but that gives us the freedom to group by almost anything and to order by almost anything, regardless of whether the column is coming directly from the database or it is a computed column like the full name or it is something external. So it gives us great freedom. You can group by anything, you can order by anything, you can count anything. The full syntax, let's see. This is the last talk, but I'm not going to keep you here for hours. So I'll skip some of the details. But you have a syntax which is a function, a source. The source is then the name of a column in your in the data source that is the provider, that is the one you actually ask for. So if you ask for the person provider, the source can be any column that the person provider actually offers up. And then you can have some modifiers like the hide detail, the footer, a few other things. One of the functions is group by. And group by is the one that you use to say, these are my buckets, these are my categories that I want to do all the counting and summing by. You don't actually have to use group by. I mean, if you just want a straight count of everything, okay, you do count, and that's it. If you do hide detail on count, the field is going to be empty. If you don't do hide detail, then it's going to be a running count up to that row. If you do a sum, then it's going to be a running sum. If you have a count or sum in a header or footer, then it's going to be the total for that group for which you have this header and footer. And group by is independent of order by. You can also group by multiple fields, so group by first name, last name, or you can do nested groups. Group by this, then group by that. And you can nest as far as you want. And to give you a flavor of what we're offering, so you have a count of unique values, count of all rows. So if you have duplicates, that's fine, we'll count them. Sum, percentage of total, average, median. And by the way, all of these are plugins. If you have a good idea for your own function, you can write a plugin. It slots into this, then you can call on it from the outside. Your code gets executed. We have a lot of different date parts. So you can slice the date in various ways. You can get the year, quarter, month, day, day of year. Those are numbers. You can get formatted dates. You can get day of week from Sunday, from Monday, week number. You can get compound things like year, quarter. That's going to be 2016/4. And the raw number behind it is going to be 20164, so that if you order by these, you will get them in nice chronological order. And these can be useful on their own, or you can use them inside a group by. So if you want to, you can simply use this without any grouping, without any aggregation, just to get, say, the day of week for the appointment date. So you can take out from the activity archive, you can ask for the date and the type and the text, and date part, date, day of week, and you get that. So you're not actually aggregating anything, but you're adding a calculated column, which can be useful on its own. And group by with the date part. So I'm selecting group by. I'm calculating the date part of date using the modifier year, quarter. And then I'm putting a group by around that. So I'm nesting functions. You can do that. That's fine. And the group by, I'm modifying, saying hide detail, but I do want a footer. And then I'm doing my count. And so I'm getting the number of appointments in each quarter, like this. And there's probably an order by somewhere here to ensure that I get them in this order, because that was what I wanted. Absolutely. And you can nest that in two ways. You can say, I want one level of grouping, and I'm breaking every time, breaking them down by quarter and type simultaneously. So each of my groups has a quarter and a type, and then the count for that. Or you can nest them. Within each quarter, No, that's what I said. We have no user interface for that yet. If you want to make one, that's fine, but we don't have it yet. But you can get the data that way. So that would, if you nested it, you would say group by level 1 is quarter, group by level 2 is record type. And I want a footer for each of them. And so you would get a footer for each record type with a count, and then you would get a level 1 footer with the same count fields, but this time for the whole of the outer group, for all of the quarter, all the record types within that quarter. And then we start a new outer level group, and we do the inner level groups on that again. And you can nest two, and you get the grand total at the end, which is going to be the count of everything. Yeah. The grand total is simply an invisible group level that sits around everything. And so this would be grouping by 2 fields on the same level. This would make nested groups, the outer and then the inner. And you can have as many nesting levels as you wish. You can go into double digits if you want to.
You are planning to be able to show that?
Maybe not. Maybe not. You would have to ask Erik about that. Because to be able to show it, we would also have to make it possible for users to select to do this. And we haven't yet come up with a good way of doing that. But yeah, certainly the infrastructure to do it is there. You can do some fairly deep nesting. It's quite legal to write this. Why that would be useful, I'm not sure. But you can nest and nest and nest and nest and nest. We have currency functions. We needed that for the dashboards because you're selling in all kinds of weird currencies, but you want a consistent currency unit for your pipeline. So we have currency convert, which says the first column has to be a numeric column, presumably an amount, but it could be the earnings, or it could be, any type of number, preferably something that represents money in a certain currency. Second parameter is what is the column that tells the system which currency this particular number in this particular row is in. So on sale, this would be the amount and the currency. Those are the names of those columns. And then you tell it what you want to convert it to. And so far the choice is base, own, or none. So you're not actually specifying a target currency, but you're saying convert it to the base currency as defined in the setup, or convert it to my own currency as defined in my preferences. There's a weighting function that takes a number and weights it by another number, which is understood to be a percentage. And so in the sales dashboards, we end up with this. So I've used color coding. So we weight the amount by the probability percent from the stage. We convert that to the base currency, according to which currency that amount was. We sum that, and we hide the detail. And that gives us the number that goes into the graph of what's my pipeline worth. And there's probably a group by some kind of date thing. Or there could be a group by date and associate if you want to have a graph that shows the pipeline of each, or by product, or by whatever. This is up to you. And the sale provider includes a sale quote extender. So you're getting all the quote fields. And you can dig down into that. So you can do quite a bit here if you want to. Header, footer, grand total, I think we've covered most of that. I said detail rows will have values in aggregated columns, and they will be running, so far, up to now. And the row types are going to be like footer 1, header 2. These are levels. If you don't specify a level, all your group bys are going to be interpreted as being on the same outermost level. So it's level 1. If you say anything else, fine. And if you tell me that all your group bys are on level 3, I'm going to say, okay, but you only have one level, so right, that's it. You have one level. We're trying to be tolerant. So the source is the archive provider that you requested. Remember, this whole aggregation magic is just a wrapper that the factory quietly drapes around whatever provider you requested. And so we can do something like this. The US last sales is usage statistics, last interaction with the sales client. This is the one I added in the previous talk. So this extender thing added these columns. So now I select something from a provider that contains persons, I can do this. So I want the last interaction date, and I don't want the actual date, I just want the quarter, and that's my outer nesting level. Within that, I want to group by month, and within that, I want to count the unique persons. And so I get this result. Footer 2 means this is a footer of the monthly level. And it doesn't have a value for the quarter accumulation, which is reasonable enough, I think. It does have a value for the group by month. So it's 10, so this is October. And there are 2,870 users who last had an interaction with a sales client in October. That means we haven't seen them in November. And then in November, we had 6,754 users who had their last interaction with a sales client in that month. Together, these make up the fourth quarter. There isn't any September. No, there isn't any December, sorry. Because, it's not December yet. Don't have any data for that. So the total, and so here we are on footer 1. That means it's footer for this. And there we don't have a month value, which is, again, reasonable enough because it's, which month is the fourth quarter, where it's more than one? So no value. But it's quarter number 4, and we had this many users. And this should be the sum of these two. And then we have a grand total because I asked for that. And that is more than this because my screen isn't big enough to show that we also had a third quarter and a second quarter. So I just clipped it, to make it fit the slide. So that's why we get something in the grand total. And the grand total has nothing in the group by fields because, again, it's meaningless. We are sitting outside the group bys. So there is no value for those. Do you really want to know this? Every time there is, for each group by level, there is a level object, data structure, that contains buckets. You get, for each value of a group by, you get one bin that stuff is getting put into. So if you say count appointments by record type, count appointments, group by, record type, we get a group by level for record type, and for every different record type value we see coming from the inner provider, we have a new bin. And in that bin sits a count all object. And every time we get something with that record type, we tell the count all object in that particular bin the one that corresponds to this record type, here's another. Do whatever you do. And the count will simply increase its count. Or the count all will do that. The count will keep track of its source values because it's supposed to only count the distinct ones. So it will accumulate its own little cache. And this happens for every record type, so for every value of the group by field. And the whole thing happens for every level. It's fairly straightforward, but there's a lot of stuff happening. And if you do nested functions, you get nested instances of the whole machinery sitting behind each other. And it executes from the inside out, and the data flows through the whole pipe until it hits the outermost one. And this means that there is a lot of buffering going on. So if you're doing complicated group bys, it's probably a good idea to say hide details. Unless you actually need the details. Or, I mean, if you need the detail rows, fine. If you don't need them, hide them, because then we don't have to keep track of them. And please don't fetch the whole database, because it will take some time, and it will bloat a bit. Paging isn't really meaningful combined with aggregation. I mean, count appointments by record type. And I want page 3 with page size 10. What do you actually mean by that? I want to skip the 20 first record types and then take the rest? That is what would happen. But it's not meaningful. So typically, when you're doing this, you're setting paging, you're actually turning off paging, and you do that by specifying page 0, page size, int max value. I recommend doing that. And last but not least, this is what the sum function looks like. The reason you can say sum of something is this single page of code. So it says, I am an aggregation plugin. My name is sum. That's the name of the function. And you need to override 2 methods, add item and get aggregated value. Add item gets called every time there is an item for you to get. And that item is an archive column data, which is the value of the source column that was specified when someone said sum of something. So it's up to you to parse that and get something meaningful from it. Of course, since you're inheriting from a base class, you get some, and we also have some helper functions directly on the archive column data or extension methods. I can't remember. So it's very simple. The sum, we add the numeric value we got out. And we are accumulating a double because we don't know if it's going to be an int or a double. So we're keeping track of it, but we're working with a double because that covers both cases, makes the code simpler. Get aggregated value is going to be called once, and that is when the aggregation is complete and we are in the phase where we are actually sorting and then emptying the bins and returning data to the ultimate client. So this will get called. And here, you need to return an archive column data. So in this case, we are encoding it either as a double or as an int, the sum. We're also setting the raw value item on the archive column data. And yeah, depending on whether we had seen at least one double here. And that's it. And you can imagine the average plugin. What does that look like? It does the same thing, but it also counts the number of times add item has been called. And then it does the division down here with a guard against division by 0. And so if you have an idea for an aggregation function that does something nifty that I haven't made, you make one of these, and you're good to go. And then you can call that from the outside. And that function could be an aggregation function, or it could be simply a calculation function, which you could then include in a group by. So, yeah, fairly powerful system. You can do a lot.
Split up or something like that.
Yeah, or just get the first letter of a string capitalized, so you can, order names by the first letter of or whatever. So that's up to you. As usual in the archive provider, it's plugins everywhere. So you can compose this. You can do ExtenderExtenders to add columns. You can do aggregation plugins to add functions. Then you invoke the aggregation provider from the outside and sort and slice everything. And you get some interesting results out the back. So we have used this for the dashboard interface. We haven't introduced this in the archive list user interface. You're welcome to try out your ideas. This works in online, of course. Because the
Work in the latest archive browser you have made in the SDK.
Yeah, once I post it, it's going to work there as well. Yes, yeah. I haven't actually posted it yet, but I will very soon. And of course, in online, you can't make your own plugins, but those that are there, you can call and do things with that. So we think it's a fairly robust system. Dashboard depends on it. Dashboards in service have depended on it for a year, and they seem to work. But it does go through Sentry, so you are getting the Sentry overhead. Such is life.
Can you influence performance in a way? In some systems we see dashboard performance being quite bad.
The short answer is no. If you have specific cases, then what you should do is report them, raise a ticket, see if we can find out why it's slow, and see if that is something that can be fixed. The dashboard team has done quite a lot of optimization, both on the Sentry and the archive provider engines already, to improve the performance. So maybe there is something we have missed that could be done. No, there is no, there is no magic go faster or stop checking this. No, I mean, maybe indexes, it depends on where the bottleneck is. Is it because you are doing something heavy on the database, or is it because you are fetching and filtering and counting 500,000 records? Or is it because the Sentry is too heavy on this particular item? Do you have data director sitting there eating CPU cycles with extra checks for every row? I don't know. It all depends. So if you have a specific case, I think we'll be happy to investigate. There are some people smiling in the back. Okay, that's it for the aggregation provider. I hope you like what you see.